Okay, pay attention to this brief video tutorial. It will show you how to measure the velocity and the diameter of this real sample of galaxies with real spectra. I'm going to do it for this galaxy, NGC 6643. This is not one of the galaxies you're supposed to measure, but you follow the same procedure. So if I click on that, up comes the real spectrum of this galaxy. And if I move my cursor along, I can see the wavelengths. That's the top number. In this case, it's at 4064 angstroms. Now, these downward features are absorption lines. These are the two H and K absorption lines referred to in the video, in the tutorial on how to measure velocity. And this is the H beta emission line. Galaxies with emission lines are easier to measure velocities of than galaxies with just absorption lines. Some of your chosen galaxies have emission lines and some don't. But in this particular case, that's the emission line around 4800. I can left click, I can zoom in on this if I want a more precise measurement. It's not really necessary. And we know from the tutorial that this line, H beta of hydrogen, has a rest wavelength of 4861. But the observed wavelength in this galaxy is, can't really see that, there we go, about 4885. So it's roughly 25 angstroms shifted to the red. So that's the amount of redshift, 25 angstroms out of 4861. That fraction multiplied by the speed of light tells you the velocity of this particular galaxy. A couple thousand kilometers a second in this case. I can measure the same spectral shifts for this feature, which is one of the H and K lines there, and that's the other pair there. So you just go through the tutorial. You're either measuring these two lines that are around 4,000 angstroms or an emission line, which is around 4860. The numbers shifted toward larger values. The larger the velocity, the greater the shift. So that's how you can measure the velocity, but you have to read the tutorial to know what the hell you're doing. So read the tutorial. Now, the second part of this is we want to measure the diameter of the galaxy. And so you click this button that says Measure Galaxy, and up comes a frame that looks like this, where you can adjust the horizontal size and the vertical size of the window. And this horizontal alignment will rotate the galaxy like that. It is useful to rotate the galaxy so the long axis of the galaxy is horizontal on the screen. Roughly like that. Now I simply adjust the horizontal size until it's about the size of the galaxy, maybe a little bit bigger. And 117 is the number for the angular size of the galaxy. So now I have my 2 points. I have 117 and about 2,500 kilometers a second, and I put that XY pair into the plotting routine that you already saw. Now, you're going to have to come up with a fairly standard way to measure galaxy diameters. Obviously, that's not very good because it includes only a small portion of the galaxy. So in general, just try to get to the very outer part of the visible edge, because this is what Hubble had to deal with. I mean, if he only measures the inner bright part here for the diameter, he's not going to do well. So Hubble basically took long exposure photographs and tried to figure out where the end of the galaxy light was and measured the diameter. So that's the way you measure the diameter of the galaxy. I already showed you the way that you measure the spectra. Just pick up another random galaxy here, same thing. This has no emission lines, and so you got to go with the absorption line features in here, which are kind of weak. This one actually be difficult to measure. It's not in your sample, so you don't have to worry about it. Same thing, measure diameter. Rotate it so the long axis is horizontal, and then that's about the diameter of the galaxy. There's like fuzz inside of it and no fuzz outside. So it's 167 units for this particular galaxy. So that's the procedure for measuring redshifts and diameters for the 8 galaxies that you're assigned. End.